Hi, in this video, I will show you how we can create AWS Step function, which will in turn invoke the AWS Lambda function, that is AWS Python Lambda function using Terraform and deployment via GitHub Action. Deployment via GitHub Action, I mean the CI/CD via GitHub Actions. Okay, so as you see in my screen, I have Visual Studio Code being open. So in that one, I have cloned my repo from the GitHub account. Yeah, and also I have a branch with the name feature branch one, which I denoted as a development branch. Okay, yeah. So this is my complete environment is ready. I'm ready for the demo. Whereas for your purpose, if you want to know how you can configure the AWS account, GitHub repo, GitHub actions, and also AWS related configurations, please do watch my previous videos where I have explained everything from the scratch. Okay, and also a kind request, please do subscribe my channel. That would really encourage me a lot. Okay, yeah. So with that note, let's get started to this demo. So before I jump and show you the demo, I will follow the three steps. Okay, first one, I will let you know the pictorial overview of this demo, and then the next I will quickly walk you through the complete code. Okay, when I say code walkthrough, I mean I will walk you through word by word or line by line of this code. Okay, so that I will make sure that you don't need to search for the repo. Okay, whereas the for your purpose, if you want to learn from this video, please do go every seconds of the video and also copy the code line by line, because as I'm explaining word by word or line by line, you can just copy from the same by pausing the video. Okay, yeah. So with that note, let's get started to this pictorial view of this demo. Yeah, so let me open this picture. As you see in my screen, okay, so this is the picture which represents my complete demo here. Yeah, so here you go. So here it contains two big logos. Okay, one is GitHub account logo, and other one is the AWS logo. Okay, so indeed, so these are like heads of the demo. Okay, so when I say GitHub account, so GitHub account will be hosting our repo, and that repo will be in turn hosting our the Terraform file, JSON files, or the Python files, and etc. etc. Yeah. So and also the GitHub account also will be hosting a GitHub Actions. So GitHub Actions are being defined to invoke this Terraform file, which in turn will provision the required infrastructure at AWS account. Okay, yeah. So that's what I mean by this pictorial representation. Whereas at the bottom, okay, so at the bottom the pipeline says like this. Okay, so where in Visual Studio Code you will be doing an IDE, that is an Visual Studio Code is an IDE where you will be coding your infrastructure. Yeah, once you are done with the coding, you will be pushing this code to GitHub account or in your GitHub repo. So once the code pushes happens to your GitHub account, okay, so automatically the respective GitHub actions will be invoked. Yeah, so once the code comes here, automatically by push from the Visual Studio Code, the GitHub actions will be invoked. Okay, yeah. Once the GitHub actions invoke, nothing but these are running the required Terraform file. Okay, nothing but it is doing the Terraform init, Terraform plan, and Terraform apply stages. Okay, so once it does the Terraform apply the required infrastructure. Okay, so here in this demo we are focusing on how to create AWS Step function, which will invoke the in turn which will invoke the AWS Lambda function. For example, in this demo I'm showing you how you can create the AWS Python function. Okay, lambda function. Okay, Python lambda functions. Okay, yeah. So this is the complete brief about this demo. So let me quickly walk you through this code. Okay, so as you see in my screen, this is my Visual Studio Code. Okay, where I have cloned the Git repo. So this is my Git repo. Yeah, and inside this Git repo I have so let me go from the top. Okay, so I have one folder with the name .git, and after that it has subfolder called workflows. Okay, so as you might be knowing that the github / workflow folder is nothing but a folder which hosts your GitHub definitions. Okay, GitHub actions definitions. Okay, so one GitHub action definition is nothing but Terraform hyphen plan. Okay, and the name of the action is Terraform hyphen plan hyphen infra hyphen plan. Okay, so this GitHub action is meant to create infrastructure plan. Okay, it does not provisions anything, but this pipeline will be invoked every time I make pushes to my feature branch. Okay, I have two branches, one with the name feature branch one, which I denoted as a development branch. Okay, and also I have a main branch which I denoted as a production branch. Okay, so whenever a code pushes happens to my feature branch one to the upstream branch, then automatically this GitHub action will be invoked and it will do a Terraform plan. Okay, it does not provisions any infrastructure. Okay, so that is the first stage. Okay, and once we are good with the Terraform plan logs, we will be going to the next stage. Okay, that is the real time provisioning the Terraform apply. Okay, or real time provisioning our AWS infrastructure. Okay, via Terraform apply. As you see, so this is the name of my the GitHub action, that is a Terraform hyphen apply hyphen infra hyphen release. Yeah. So again, so this has been targeted on the main branch. So in the sense, whenever we make a code push from our main branch or from our future branch one to main branch, okay, so in that case, the code push happens, okay. So in that case, this Terraform apply GitHub action will be invoked, okay. This is a quite fast overview, but whereas to understand line by line of these GitHub actions, I would again recommend you to please do watch my previous videos where I have walked through complete this file line by line and word by word. Okay, yeah. So with that note, let's go to the main files. Okay, I have one more. I have one Terraform file with the name main.terraform file. Okay, that is sitting under root. Okay, so by the name, as the name suggests, like main, right? So this is the main file from where the every Terraform actions will be invoked. Okay, yeah. So let me quickly walk you through this code as well. So and in turn, this code will be invoking the other two folders, that is the Lambda function and the step function via modules. Okay, I will explain that while going through this code. Okay, first let's go to this one. So first one, this block. Okay, so this is the Terraform backend configuration block. Yeah, so this block contains the Terraform backend configurations first, that is a bucket data and the keyword. Okay, so as you see here, so this is my bucket, and inside this bucket I have a state file. Okay, so this state file will maintain the infrastructure state. Okay, yeah, and the reason is US East. Okay, so I'm keeping it in US East. Okay, so this is like a pre-created Terraform backend configurations, which Terraform will be using it for infrastructure as a code or versioning purpose. Yeah, and after that I have the two providers, one with the name random. Yeah, and also I have the two region provider. One is meant for US East, and the other one I mean for the US West one. Okay, whereas since US East one is the primary one and US West is the second one, henceforth I have added alias for the second location. Okay, yeah. So with that, let's go to the next blocks. Okay, as you see in the next block. Okay, so the next two blocks are the Terraform custom modules. Okay, so Terraform custom modules, which will invoke the Terraform invocation will be passed from one folder to other folder. Okay, so this is how we do it. Okay, via modules. Okay, yeah. So this is the block. We will call it as a module block. Okay, so this module with the name AWS Lambda function. Okay, so as the name suggests, this is the block which creates a AWS Lambda function. Okay, because since this demo is meant for creating the AWS stem function. Okay, which will invoke the AWS Python Lambda function. Okay, so in this case, the prerequisite is our AWS Lambda function, right? Henceforth, we are invoking the AWS Lambda function creation at the first. Okay, yeah. So as you see here, the module, okay, the module invocation, the source, okay, the source path of this module is root and the Lambda function. Okay, that is nothing but root and Lambda functions. Okay, so let's go to this one. So whenever this module executes, the runtime of Terraform will directly invoke to this folder. Okay, nothing but dot lambda function. So this is our dot lambda function. Okay, it contains multiple files. Okay, so let me briefly tell you what this folder is meant for. Okay, this folder contains a Terraform logic which will provision the required AWS Python Lambda function. Okay, in general, yeah. So let me quickly walk you through this Terraform file, that is AWS Lambda within Lambda functions folder. Okay, whereas the other files like example.python, nothing but an example function. Okay, nothing but Lambda function, that is, yeah. And also other role and policy JSON files, I will explain those while I am walking through this file as well. Yeah, so we are now inside the Lambda functions folder via module. Okay, via from here. So from here, now the code invocation came to this Terraform file. Okay, yeah. So let's walk from the top to bottom of this Terraform file. Okay, yeah. So here, let me reiterate again. So this Terraform file is meant to create AWS Python Lambda functions. Okay, so first one, this is the block. Okay, in this block, what I am doing is I'm creating an archive file. Okay, I'm creating an archive file of archive folder of example.python file. Okay, so what I'm doing is I'm creating an archive folder, that is example.zip file for this example.python file. Okay, because this zip file will be consumed down the code while creating the Lambda functions. Okay, so again, this is a data. Okay, so creating the zip file archive file is a data in Terraform. Again, the resource type is archive underscore file. This is my variable. Inside this flower bracket block, we are giving the type of the archive file. Okay, this is a zip. Okay, so yeah, and the source file. Okay, the source file is, as you see here, the source file is my Python file. Okay, this is our function file. Okay, I will walk you through this file as well. So before we go there, so this is my example.python file, as you see here. So this is the syntax of how you can create an example. Okay, an example Python functions in AWS Lambda. Yeah. So here we are importing the logging module. Then we are creating a variable pointing to logger. Okay. Yeah. Indeed, nothing but it is having the logger functions data. Okay, and it has a set label. Okay, nothing but you are setting the logging info. Yeah, and after that, this is the function. Okay, this is the handler function. Okay, which we'll call it as handler function. What it does is it will use the logger object informations. Okay, and it will just return. Okay, it will just create a event in the form of a key and value, and it will just return the event. Okay, yeah, and an object. Okay, so that's it. It is just an example Python function in AWS Lambda. Okay, so that's what, let me tell you. So this is the file which we will be call it as a function inside our Lambda, AWS Lambda. Okay, yeah. So that's what this source file is meant for. So the zip file will be created out of this Python file. Okay, so that's what the output path is says. Okay, yeah. So that's all about the archive code block. Okay, so next one, what I'm doing is I'm creating an AWS S3 bucket. Okay, so why I'm creating AWS S3 bucket is I will be using the AWS S3 bucket to keep the versioning of this .zip file, nothing but versioning of our example Python functions. Okay, so for that purpose we need a S3 bucket. That's the reason we are creating this S3 bucket using this block. Okay, so this is the Terraform block which is responsible for creating the AWS S3 bucket. It's a resource. This is the resource type, that is AWS underscore S3 bucket. Yeah. And this is my variable. Inside this flower bucket block, we are giving the required parameters, that is the bucket name. ACL is private, and the tag, okay, is a tag name equal to, I'm just giving an example tag name. Okay. Whereas you can change this bucket name and the tag name according to your request. But when you are making these changes, make sure that you are making the parallel changes across the code as well. Okay, and the next code is to upload a zip file. Okay, the zip file which we created above will be uploaded to this S3 bucket which we created above by via this code block. Okay, so this is the code block which will update an object inside the S3 bucket. Okay, so again, so this is a AWS S3 bucket object. Yeah, so that is the resource type. This is the variable. Inside this flower bucket block we are giving the required parameters for this task. Okay, this is a task, and in Terraform it will again called as a resource. Okay, yeah. The bucket ID, as you see here, the bucket ID is being referenced from the above attribute itself. Okay, above S3 bucket definition attribute itself. Okay, and this is the key. So the key of the object I'm just giving it as example.zip. Okay, yeah, and the source path is nothing but it is referencing from the output of the zip. Okay, output of the zip module. Yeah. So that's it. So this is where the bucket S3 bucket will be created. Inside this bucket, the dot required dot zip file will be put in there. Yeah. And after that, so as you know that to create AWS Lambda functions, we need to have a role and the role policies. Okay, so that's what being done here. So first one, we are creating a AWS role for the Lambda. So this is the block which does that. Again, it's a resource, yeah, and this is the resource type, that is AWS underscore IAM underscore role is the resource type to create the role. Yeah, and just this is just a variable inside this flower bucket block. We are giving the name. Yeah, so this is the name of the my role. Yeah, and the assume role policy. Okay, so role policy is a JSON file. So let me quickly walk you through that JSON file as well. Yeah, so this is the JSON file which is meant to create a Lambda functions role. Okay, so again inside this statement we are just giving we are just allowing the action logs and effect is allowed. Okay, so we are just allowing the all permissions on the logs. Okay, yeah, so that's what the role tells all about. Yeah, that's what the role will be created about. And after that, to that role we are attaching a policy via this code block. Okay, so this is the block which does that. So let me quickly walk you through this block as well. Again, it's a resource, and it's again IAM AWS underscore IAM underscore role underscore policy. Okay, so this is the resource type in Terraform which will bind the role and policy together. Yeah. So again, it's a variable inside this flower bucket block. We are giving the required parameters. That's the name of the policy and the role. Okay, the role will be referenced to the above attribute itself. Okay, as you see, so when I'm selecting this one, it is referencing to this. Then this is the variable, and the ID attribute will be used here for the role. Yeah, And the policy again is a JSON file. So let me quickly walk you through that JSON file as well. So this is the JSON file for role policy, okay, that for Lambda role policy. Yeah. So again, inside this statement, we are allowing the action, that is action is STS colon assume role. Okay. So inside this the service, okay, the principal will be pointing to the AWS service, that is a Lambda service, and the effect is allow. Yeah. So that's what being defined in the role policy. Okay. And finally, we are creating the AWS Lambda. Okay. So we are creating the AWS Lambda function. Okay. So AWS Lambda functions will be created via this code block. Okay. So this is the block which is responsible for creating the AWS Lambda functions. It's a resource inside this AWS. This is the resource type, that is AWS underscore Lambda underscore function. So this is the resource type in Terraform to create AWS Lambda functions. Inside this, this is the variable. So inside this flower bucket block, we are giving the as usual required parameter. One is the function name. Yeah. So this is the function name which I'm giving just an example. Yeah. So we have created above this block, we have created multiple services and resources, right? So those services will be consumed here. First one, the bucket. Okay, the bucket which one will be we created will be consumed here, will be referenced here. Okay, this is the AWS S3 bucket. This is the variable, and the ID will be consumed here. So inside this bucket we have a key. So this is the example key. So nothing but, so this GIF file will be used by the Terraform to publish a function inside this Lambda. Okay, yeah, yeah. So again, it's a role. So role is the same role which we created above, will be referenced here. Handler. So handler, I'm just giving as an example dot handler. Okay, because my file name is example dot Python, right? So we are using that as a handler for this function. Yeah. And the runtime. So the runtime is since it's a Python function, I'm using the Python.38 as a runtime for it. Okay. And finally, the output. Okay, the output of this model is something like this. I have created. Okay. So what it does is it will retrieve, it will return. So okay, whenever this model, nothing but a Lambda function model runs. Okay, so that model will return something. So okay, that can be used for the next modules or next iterations of the code. Okay, so let me tell you like this. Okay, this code. Okay, this code of this block is responsible for giving an output or returning something. Okay, so what does this return is, it will return an ARN of the Lambda function which we created. Okay, yeah. Okay, so this will be stored in this output. Okay, yeah. So with that note, let's go to the next block. Okay, so we are done with this module. Okay, let's go to the next one. So next module is meant to create AWS Step function. Okay, which is our targeted resource. Okay, so this is the module which will take us to the next folder under the our repo, that is stuff function. Okay, as you see here, the stuff function, which yeah, so here's the stuff function. So this will direct us to here. Okay, so it contains only one Terraform file. Okay, this Terraform file is meant to create AWS stuff function. Okay, it contains end-to-end definitions of how you can create AWS stuff function. Okay. So let me tell you one thing. As I explained, right, in this module, so this module will be returning Python AR, nothing but our AWS Python Lambda functions ARN will be returned, right? So that will be consumed here. Okay, so I need that ARN while creating the AWS step function. Okay, henceforth I was returning from here and will be consumed here. Okay, yeah. And this is the variable I have given, and this variable will be carried forward during to this step function folder. Okay, so inside the step function folder we have one other Terraform file with the name step functions.terraform. Okay, so again, so as I explained, so this is the variable. Okay, this is the variable which I was passing, and it is been invoked, or it is been initialized here. Okay, so variable the Python functions. Okay, the name should be same. Okay, let me make a note. So whatever the variable we are passing here, so should that name should be here as equal as same that. Okay, as same as that was. Yeah. Again, so this is a variable, so that variable will be consumed down the code. Okay, so I will explain that how we can do that. Again, as you might be knowing that to create every AWS functions, or to create every AWS stuff functions, we need a role and the role policies. Okay, so that's what I'm doing here now. So this is the code block which creates IAM role for AWS stuff function. Okay, so let me quickly walk you through this code block as well. So again, so this is a resource, and it's AWS IAM role. This is the variable inside this flower bucket block. We are giving the required parameters. One is the name of my AWS IAM role. Yeah, so this is the big name which I'm giving to it. And the assume role policy, the assume role policy for step function is like this. Okay, it's again, so instead of giving the JSON file here, I'm directly pointing to object. I'm pointing to object which is nothing but a JSON file. Okay, JSON file in the Terraform code itself. Okay, so yeah, so instead of referencing to a JSON file, I'm just integrating inside the Terraform block itself. Okay, so that's what we are, and this is will be done via this syntax. Okay, remember that. So the syntax will start with the smaller than hyphen eop, yeah, eof, okay, and ends with eof, yeah. So inside this, yeah, starting with eof, and the flower bucket starts, okay, where the complete JSON format will be given, yeah. Inside these statements, we are giving the assume role, and the service will be our, as you see here, it says states, okay, nothing but a step function, yeah. So that's what bin will be created here in the AWS step function role. Okay, so the same role will be consumed down while creating the AWS step function role policies. Okay, so this is the policy which will consume the above role. Okay, or we are attaching this policy to that above role. Okay, in other words. So again, it's a resource, and this is the keyword. Okay, that is AWS underscore IAM underscore role underscore policy. Okay, this is the same like resources we created for the AWS Lambda functions. Okay, this is, and now we are creating for AWS stuff functions. Okay, to make you clarify. Again, this is the variable inside this flower bucket block. We are giving the required parameters. One is the name of the role policy, and the role R. Okay, so this is the role ID which will be referenced from the above role. Okay, yeah. So let me show you that. Okay, so here you go. If I'm selecting here, that's getting selected here, right? So yeah, that's the reason it says that it is referencing step functions and then ID. Yeah, so that's what. And after that, again the same thing. Okay, we are using the smaller than hyphen EOP, and ends with EOP. Nothing but we are putting a JSON formatted body inside this EOP block. Okay, so inside this EOP block, nothing but the policy. Okay, the power policy. What does this policy says about all about? Yeah, again it's a version, and inside the statements we are giving the required actions, that is the invoke function. Okay, what actions, what are the actions which are we are allowing via this role is we are allowing the invoking the functions. Okay, so that's what our target is. Okay, we are creating a stuff function, and to that stuff function we are giving some permission so that it can invoke the respective AWS Lambda functions. Okay, here in our case an example Python Lambda function. Okay, so that's the reason we are giving this action, and the allow is the effect is allow, yeah. And as you see that, right, so as you see, right, we are consuming the resource ARN. Okay, on which resource the permission is been given, right, nothing but the AWS Lambda function which we created just a while. Okay, while, right, so that ARN will be passed here via variable. Okay, and it is been referenced here, yeah. So this is the variable. Okay, this is the variable name which we declared above. Okay, and it will be referenced via var dot and that variable name, yeah. And where the value returned by this block is nothing but ARN of our AWS Lambda function which we created just now, yeah. So that's about the role policy for step function. And the final block, okay, this is the final block of creating the AWS state function, or for state machine. Okay, yeah. Again, so this is the block which is responsible for creating that step function or state machine, yeah. So inside this, so let me quickly walk you through this block as well. So this is again a resource, and this is the resource type to create this state machine, that is AWS underscore SFN underscore nothing but state function. Okay, state function underscore state underscore machine. Okay, this is nothing but creating a step function resource type. This is the variable inside this flower bucket block. We are giving the required parameter. One is the name of our step function, and the role. Okay, the role will be the same role which we created above, and the definition. Okay, so how this your stuff function or the state machine should look like. Okay, or what it should do, yeah. So that definition will be given in this JSON format inside the EOF block. Okay, one is the command. The command says the invoke the AWS Lambda from AWS step functions with Terraform. Okay, so that's what I just given the general definition of our stuff function. Okay, again starts at example. So this is the name of the stage. Okay, this is the name of the stage in the AWS step function. Okay, and inside this state, okay, nothing but the state. Okay, there are multiple states in the AWS step function. Okay, in this one we are consuming the task. Okay, we are taking a task kind of a step function. Okay, and the resource. Okay, the resource is nothing but again our AWS Lambda function ARN. Okay, so as you see here, so it's a variable, and the this is the variable which we explained just a while. Okay, so nothing but the resource is nothing but it is pointing to the same ARN value of our AWS Lambda Lambda function which we created just now. Yeah. Okay. So that's it. So and end is true. Okay. So it will giving the value as end equal to true. Okay. So that's it. This is the definition of our step function which will invoke our AWS Lambda. Okay. AWS Lambda function. Okay. So that's it. I have cleanly walked you through the line by line code of this demo. Okay. So now with that note, let's get started to the demo. Like I will show you how we can create these resources via GitHub Action, nothing but a CI/CD tool. Okay, yeah. So let me make some dummy commits so that I can commit and show you the resource creation process. Okay, so here you go. So I have committed some changes. So let me make a commit to my local branch. Okay, AWS. I'm just giving some meaningful messages. Okay, message. Okay. So I will commit this change to my local branch. Okay, nothing but my branch which is sitting in my laptop. That is the feature branch one. Okay. So as you see here, the synchronization says that there is a one change needed to be upstream synchronized. Okay, upstream is nothing but the repo or the 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 repo. Okay, so the upstream so upstream is nothing but the our GitHub accounts. Okay, so GitHub account, in that GitHub account we have a branch. Okay, so that branch will cut as upstream branch. Okay, that's what this synchronization says. Okay, nothing but there's a change needs to be synchronized in our upstream branch, which is nothing but a feature branch one. Yeah, so let me make a synchronization to my upstream branch. Okay, with this. Yeah. So once this finishes, I will take you to the GitHub account and I will show you that how we can invoke the Terraform plan and Terraform apply GitHub actions. Okay, yeah. So currently it is running. So let me while it is running. So yeah, here you go. It has successfully completed the synchronization. So now let me take you to the GitHub repo. So this is my GitHub repo. Okay, in this GitHub repo, it has two main branches. One is the main and other one is the, so let me show you clearly. So it contains two branches. One is main branch, other one is feature branch one. Okay, so just now we made code pushes to feature branch one. Okay, so that would invoke a GitHub action. Okay, I have two GitHub actions indeed, two GitHub action workflows indeed. So in that one, the Terraform hyphen plan hyphen infra hyphen release. Okay, infra hyphen plan. So this is the name of the Terraform plan GitHub action, which got just now invoked. Okay, so this is the it has successfully invoked indeed. So let me quickly walk you through the Terraform plan logs as well, so that you can understand what actually it's going to do in the AWS account. Okay. Later to this, we go for the Terraform apply stage. Okay, yeah. So here you go. It successfully ran the Terraform plan stage, and it says that it's going to create multiple resources. In that one, the Lambda IAM role. Okay, so this is the Lambda IAM role, and after that, it is creating a Lambda policy for IAM role. Okay, and also it is creating the Lambda functions finally. Yeah, and it is creating a S3 bucket which we define in for the Lambda functions, and it's adding an object inside that S3 bucket, and it's also creating a step function. Okay, a step function role as well, similarly attaching a policy to that step function role as well. Yeah, so this is the one, and finally it is creating a step function. Okay, nothing but a state machine. Okay, yeah. So fine, in total, what our Terraform plan stage says is it's going to add eight resources to the AWS account, zero changes and zero dust. Okay, so that's what the Terraform plan says, and I believe that we are happy with it. Okay, because we want that. That's what, like, right? We want that infrastructure to be provisioned to our AWS account. Okay, yeah. So with that, let's go to the next stage. Okay, to invoke the Terraform apply GitHub actions, I need to create a pull request against my future branch to my main branch. Okay, so let me do that. Here you go. So I'm creating a pull request now so that the changes will be merged from my feature branch one to main branch. Okay. Why I'm doing this is so whenever I make some code pushes to my main branch, then only the Terraform apply GitHub actions will be invoked. Okay. So that is what the strategy is being defined for CI/CD tasks via GitHub actions. Okay. Again, to learn more about this one, I would again recommend you to please do study my previous videos where I have explained everything in regards to this one. Yeah. So let me make a merge. Okay, my confirming merge is nothing but you are pushing the codes to our main branch. Okay, so once the code is pushed to our main branch, then automatically it will invoke Terraform apply GitHub Actions. Okay, as you see here, the name is big. That is Terraform hyphen apply hyphen infra hyphen release. Okay, nothing but this will do infrastructure release. Yeah. So as you see here, so that that the apply, okay, the Terraform apply has been invoked now. It is running currently. Yeah. So once the Terraform apply is completed, I will show you the demo of how we can invoke the step functions to invoke the Terraform to invoke the our required AWS Lambda functions. Okay, here you go. It is very quick. It has successfully provisioned the required infrastructure. Okay, currently it is provisioning. Okay, so once the provision is successful, I will quickly walk you through the this Terraform apply logs as well. Okay, and after that I will show you a demo that how invoking step function will in turn invoke AWS Lambda functions as well. Yeah. So currently it has successfully provisioned the required infrastructure at our AWS accounts. So that's what the Terraform apply log says. Okay, here you go. Okay. So first one, here you go. It has says like it has created the it is refreshing. Okay, it says refreshing, and here you go. It's creating the role. It's creating the multiple services. Okay, like yeah, I would again recommend you to slowly walk through these logs. That would really help you to understand how the Terraform works. Okay, and finally it says that it has apply is complete. Okay, and resources. Okay, then resource summary, it says that it has added 8 resources. Okay, the resources which we saw in a Terraform apply stage. Okay, zero changes and zero dust. Okay, so that's what we want, and it has successfully provisioned the required infrastructure at AWS console. Okay, so AWS account. Okay, let's go to the AWS console. Okay, so this is my AWS console where I was doing my task. Okay, so first one, let's refresh the S3 bucket if the S3 bucket has been created for us. Okay, wherever we are keeping the .zip file which is required for AWS Lambda functions. Okay, so this is the bucket which got created via our Terraform apply stage. Yeah. So here you go. The example.zip file has been folder has been created inside this S3 bucket, okay? And this zip file will be used by our the Git via our S3, this one, right? Our Lambda functions. Okay, yeah. So now let me take you to the Lambda functions. I will show you that whether that has been created or not. Okay. So first one is the AWS Lambda function. Okay, yeah. So I'm just take you to the Lambda function. So here you go. The Lambda function has been created. Our name I have given is example. Okay. So that Lambda function has been successfully created. Let's see the if it has the same Python code which we saw down here during the code walkthrough. Okay. Um, so let me show you that file. So I need to click on this one. So here you go. Yeah. So it contains example. Yeah. It contains example.python file. Yeah. So nothing but the same code has been came now in the AWS Lambda function, and that will be called. Okay, that will be called whenever the AWS step functions gets invoked. Okay, yeah. So don't so since the words are similar, don't get confused. Okay, so first name is step function. That is AWS step function will invoke the AWS Lambda functions. Okay, so yeah. So with that, let's go to the final destination service, that is step function. Okay, so this is the step function console. So let me go to the step function console. So this is the step function console, and our step function has been successfully provisioned. Yeah, here you go. The status is active. Yeah. So let me open this and I will show you the test execution of this step function. Okay. So here you go. Okay. So let me do. So this is the step function which we have created, and it will invoke. Okay. What it will do is it will invoke the respective, what is that? It will invoke our AWS Lambda function. Okay. Yeah. So let me give a demo of this one. So let me click on the start execution. Okay. So let's give it as a test hyphen demo. Yeah. And inside this commit, I will just give video demo. Yeah. So let me start this execution. Nothing. See here, I'm invoking the step function. Okay. I'm not invoking AWS Lambda function. Okay. So that's what the step function will in turn invoke the AWS Lambda function. Okay. Yeah. So that's what I want to show you here. So here you go. So we have invoked a step function, and that is in turn has invoked our AWS Lambda function. Okay, here you go. The example Lambda function is nothing but our function which we created just ago. Okay, it has successfully ran. Okay, and let's see what is the output of that one. Okay, so here you go. Okay, So here the comment which we gave has been came, that is a video demo, and the output of the stuff function is nothing but an example key and value output which I have shown in the code. Okay, so that is our demo channel, and this is the key, and this is the value has been printed out by that step function, by that lambda function, okay, which is written in Python. Yeah. So that's it. So this is like I believe that you have understand that how AWS step functions can be used to invoke the AWS Lambda functions. Okay, yeah. So indeed, till now you might have understood that what is the reason of the AWS step function. Okay, so these step functions will be used for orchestrating our microservices in AWS. Okay, for example, here the microservice is an example. Here is our Lambda function. Okay, so that is a kind of microservice which will be invoked by step function. Okay, so like this you can do multiple invocations and multiple chain invocations one after the other using this step functions. Okay, yeah. So with that note, we have successfully shown you the end to the scratch to end demo of how you can create the step functions, and how that the same step functions can be used to invoke the AWS Lambda functions, which is written in Python. Yeah, yeah. So it's complete pure demo. Yeah. I believe you have understood, and you understood and liked this video. So finally, thanks a lot for watching our videos. Kind request, please do subscribe my channel. That would really encourage me a lot. Okay. With that note, thank you. Thanks a lot.